Welcome to this video on the topic of matrices. In this video, we'll be having a look at how we can perform matrix multiplication on rectangular matrices. Now, matrices of differing orders may be multiplied together provided they are what's called conformable. Two matrices are said to be conformable if the pre-multiplier's column count is equal to the post-multiplier's row count. Looking at matrices A and B, the order of matrix A is going to be 2 and 3, and the order of matrix B is going to be 3 and 1. So 3 columns, 1 row. Looking at the conformability check, the pre-multiplier's column count. So what we're looking at is this second item here, 3. Going for matrix B, the post-multiplier's row count, as seen 3 here. Now, because for matrix A and matrix B, the pre-multiplier column count and the post-multiplier row count are both in agreement, so 3, matrices A and B are said to be conformable, and as a result, they can be multiplied together. However, if we try and go in the opposite direction, so if we multiply B by A, what we're going to find is that they're not conformable, so that sort of multiplication is not possible. Now, going down, if we're multiplying matrices of different orders together, what we're going to find is that we're going to get a resultant matrix of a completely different order altogether to A and B. The order of the resultant matrix is defined by the rows of the pre-multiplier and the columns of the post-multiplier. So, observing that if we go A multiplied by B, we're going to get a resultant matrix of C. Now, the order of A, as we saw above, is 2, 3, and the order of B is going to be 3, 1. What we're going to find is that we get a subsequent order for C, which is different to both of these guys. Now, for A, we're going the rows of the pre-multiplier, so that's 2. And then we're looking at the columns of the post-multiplier, which is 1. This is going to end up in a result of a resultant matrix being of order 2, 1. So notice the two patterns we abide by. To check whether we can actually multiply two matrices together, simply line them up and see if the two inner numbers match. And then to determine the resultant matrix, go for the two outer numbers, so 2 and 1, and that will give you the size of C. Now, going in for a more tangible example, let's multiply matrices A and B together to get resultant matrix C. Now, A is defined as 3, 2, 5, 2, 4, 7, and B is defined as 4, 2, 3. Multiplying these together, we're going to get a matrix of order 2 and 1, so 2, 1 as shown here. So that's going to be 2 rows, and then we're going to get 1 column. So we're expecting a matrix that will eventually look like this. Now, writing this out, we're going to get 3 multiplied by 4 plus 2 multiplied by 2 plus 5 multiplied by 3. So that's our top element, and then our second element is going to be 2 multiplied by 4 plus 4 multiplied by 2 plus 7 multiplied by 3. Continuing the calculation, we're going to get 12 plus 4 plus 15, followed by 8 plus 8 plus 21. Crunching these numbers, we're going to get 15 and 4, that's 19. So that will become 31 in total. And then the final one will be 8 and 21 is 29. So that will be 37, like so. This is C. Now, checking this on our calculators, multiplying these together, I go option F2, then I'm going to set this up. So F1 alpha A, F1 alpha B, and thus what I end up with is a 2 by 1 matrix, 31, 37. Alright, so that's example 1. Let's go down for something a little bit more complicated. Let's go for example 2. The multiplication of C and D. C and D being a, or C being a 2 by 3, and D being a 3 by 2. Now checking the orders here, we have a 2 by 3, and for D we have a 3 by 2. So what we find is that because they're both inner a 3, they're definitely conformable, and the outer is a 2 by 2. So we're going to get a resultant matrix if we define CD, the resultant matrix is going to be a 2 by 2 matrix, so it will be nice and neat like that. Now jumping into it, we're going to go rows and columns. So going across the rows and down the columns. We're going to go 1 by -5 plus. Now one strategy you can employ, just in case you feel like you may have made a mistake in the calculations up here, is rather than doing the shortcut and allowing the columns to propagate down and the rows to propagate across, you can keep doing the calculations manually each time. So you go 1 and 5, 3 and 2, -2 and 1, and then when you get to this row down here, go 4 and -5, 2 and 2, -1 and 1. And you should see the values match as you're going down across like this. If they don't, then you know you've made a mistake. So I'm not sure if I've made a mistake, so I'm going to use that practice. Alright, so it seems to be okay. Computing these numbers, we're going to get -1, it seems, 4. Verifying our results on the calculator. We indeed get -1, 4, -17, and -5. Now, in summary, what we set out to do in this particular video was we wanted to have a look at how we could perform matrix multiplication on rectangular matrices. What we found was that we can only perform matrix multiplication if the matrices are conformable